The maps in every classroom are officially outdated.
A recent study has shown evidence that another continent exists on planet Earth.
Researchers just finished a massive project to map the entire 8th continent of Earth. It is called Zealandia, and it is a 2 million square mile giant sitting at the bottom of the ocean.
It's been there for 100 million years, but it's newly discovered, and that's because it's been underneath the ocean and hiding.
Most people thought it was just a bunch of broken islands, but the final map proves it is one solid, massive continent. The rocks found at the bottom tell a story of a world that stretched until it literally snapped and sank. This is the most complete look at a hidden world we have ever had. Ancient land finally found. Recent studies have shown evidence that another continent exists on planet Earth. Most people think there are only 7 continents because that is what is taught in every school, from New York to California. But scientists have just finished mapping something that has been hiding beneath the Pacific Ocean this entire time. It has been there for 100 million years, but it is basically a brand new discovery because it has been tucked away under the waves. We are talking about a massive landmass, nearly 2 million square miles in size. It is called Zealandia, and geologists are calling it Earth's 8th continent. The stunning part is that we are only now seeing the complete picture of this hidden world. For the first time, researchers have mapped every single corner of this submerged giant. And what they discovered is rewriting everything we know about the geography of our planet. Imagine a continent so massive it is 20 times the size of New Zealand. Yet 94% of it sits underwater, where no one can see it. That is exactly what scientists finally mapped in its entirety, and the results are staggering. The breakthrough came when a research team used heavy equipment to dredge up rock samples from the deepest parts of the Pacific Ocean floor. What they found was not just ordinary oceanic crust. These rocks told a completely different story. They found sandstone dating back 95 million years and granite pebbles from 130 million years ago. They even found volcanic basalt that formed 40 million years ago. Each sample added another piece to a puzzle that revealed something extraordinary. An entire continent had been hiding under our noses the whole time. Nick Mortimer and his team at GNS Science spent years analyzing these samples and comparing magnetic signatures to map the geological boundaries. When they finally completed the work, they had documented nearly 2 million square miles of continental crust sitting beneath the Pacific. This was not just fragments or scattered islands, but a complete unified continent. The last unmapped section was North Zealandia, which stretches from Fairway Ridge to the Coral Sea. Without that final piece, scientists could not definitively prove the true size or boundaries of this place. Now they could. Scientists finally mapped Earth's hidden 8th continent from end to end, and the picture they revealed was stunning. It is a drowned world, larger than India just beneath the waves. Here is what makes this discovery so significant. Zealandia is not some small microcontinent or a collection of underwater fragments. It is a legitimate landmass with clear geological boundaries that are distinct from the surrounding ocean floor. The rock composition and the thickness of the crust point to one conclusion. This is a continent. But here is the catch. Almost all of it drowned millions of years ago. To understand how that happened, we have to look at what little remains above the surface. Right now, only about 6% of Zealandia breaks the ocean surface. New Zealand is the most obvious part, which includes 2 large islands that millions of people call home. New Caledonia sits to the north, and scattered around them are smaller islands that look like tiny dots in the vast Pacific. Everything else lies submerged, thousands of feet below the surface. Mountain ranges stretch across the seafloor, and ancient river valleys wind through landscapes no human will ever walk through. Coastlines that once felt wind and rain now exist in permanent darkness. For almost 400 years, scientists suspected something massive existed down there. The clues were always there, hidden in the unusual thickness of the seafloor and in the unexpected rock types pulled up by research vessels. They just could not prove it. The technology to properly map underwater terrain did not exist until very recently. Early oceanographers used basic sonar, which provided rough depth measurements but very little detail. They knew the Pacific had ridges and plateaus, but they assumed these were just features of the ocean floor and not remnants of a sunken continent. Advanced seismic imaging changed everything. Scientists could suddenly peer through thousands of feet of water and sediment to examine the actual rock structure beneath. They discovered that what maps labeled as ocean floor was actually something else entirely. It was continental crust, just like the ground beneath North America or Africa. The thickness gave it away. Continental crust is very thick and is usually between 15 and 40 miles deep. Oceanic crust, by contrast, is thin and usually only about 4 or 5 miles deep. When researchers measured the seafloor of the South Pacific, they found crust far too thick to be oceanic. Even though this crust was thinner than typical continental crust, because it was stretched thin by geological forces, it was still unmistakably continental. That is when the realization hit. They were not looking at an ordinary ocean basin. They were looking at a drowned continent, and it was huge. The question that haunted researchers for years was very simple. How does an entire continent just sink? The crazy part is that we might be walking on the only tiny pieces left of a lost world. Giant landmass pulled apart. For decades, geologists thought they understood how Zealandia broke away from its neighbors. The theory involved something called strike-slip faulting, which is when tectonic plates slide past each other horizontally. It is like two hands rubbing against each other. That is how they assumed Zealandia split from Australia and Antarctica millions of years ago. But the rock samples told a different story. When the team analyzed the geology of North Zealandia, they found evidence of something else entirely. The crust had not just slid apart, it had stretched. Picture pulling a piece of taffy, or pizza dough. As you stretch it, the material gets thinner and thinner, until eventually, if you keep pulling it, tears. That is exactly what happened to Zealandia. Tectonic forces beneath the continent pulled it in different directions and stretched the continental crust until it became dangerously thin. The stretching direction varied by up to 65 degrees across different regions, which created uneven stress throughout the landmass. Eventually, the crust stretched so thin that it cracked open. Ocean water rushed into these cracks and flooded the spaces between the separating landmasses. The Tasman Sea formed in one of these gaps, which created the body of water that now separates Australia from New Zealand. A few million years later, more tectonic activity continued the stretching process. The crust grew thinner still. Large sections began sinking beneath sea level because the weakened continental material could no longer support its own weight above water. By the time the process finished, Zealandia had descended into the ocean. This discovery matters because it rewrites our understanding of how continents break up. If stretching played such a major role in Zealandia, it might have been involved in other continental splits that geologists thought they understood. The process that scientists finally mapped in Zealandia could help explain geological mysteries elsewhere on the planet. None of this happened in isolation, though. Zealandia's fate was sealed long before it even separated from its neighbors, back when it was still part of something much larger. It is not that simple, though, because we are talking about forces so big they move entire oceans. Basically, this continent was doomed the moment it started to move. The stretching was not just a small event. It was a massive geological disaster that took millions of years to complete. And get this, the continent is still moving and changing even now. What most people do not realize is that the Earth is not a finished map. It is a work in progress. Yeah, about that whole sinking thing. Most people think a continent sinks because of a flood. But this was a slow-motion descent. It was a giant landmass being pulled apart by the very planet it sat on. The crust became so thin, it basically lost its ability to float. Every year, it sank a tiny bit more until the waves finally claimed it. And that is putting it lightly, because we are talking about millions of square miles of land just disappearing into the blue. If this could happen to Zealandia, scientists are now wondering if it could happen to other places. The continent that drifted away. The story of Zealandia begins with Gondwana, which was the ancient supercontinent that dominated the southern half of Earth. About 200 million years ago, most of the land in the southern hemisphere was jammed together into this massive formation. South America, Africa, Antarctica, Australia, and India were all connected. They formed one continuous landmass. Zealandia was part of that supercontinent, wedged between what would eventually become Australia and Antarctica. For millions of years, these lands existed as a unified whole. They shared ecosystems and geological processes and a common history. Then Gondwana started breaking apart. The process took millions of years and happened in stages. Different pieces split off at different times and drifted away on tectonic plates that moved at the pace of growing fingernails. Slow but relentless. South America and Africa separated, which created the South Atlantic Ocean between them. India broke free from the eastern edge of Gondwana and began its long journey north, where it eventually collided with Asia to form the Himalayan mountain range. Australia pulled away from Antarctica and opened up the Southern Ocean. This separation happened around 85 million years ago. Zealandia finally split from its neighbors and became an independent continent, drifting on its own tectonic plate. At first, it remained above water and was a landmass comparable in size to the continents surrounding it. That is when the stretching began. The same tectonic forces that separated Zealandia from Australia and Antarctica continued to pull on its crust. As the crust weakened, the continent began its slow descent beneath the Pacific. This process makes Zealandia unique among all the continents on Earth. Other breakaway pieces from Gondwana remained above water. Australia stayed high and dry. Antarctica remains a landmass even though it is covered in ice. Even smaller fragments like Madagascar stayed above sea level. Only Zealandia sank. The evidence of exactly how and when this happened was locked away in rocks scattered across the seafloor. These were rocks that scientists needed to physically retrieve and analyze to tell the story. For starters, they had to find a way to get to the bottom of an ocean that is miles deep. Hands down, this is one of the hardest places on Earth to study. But the researchers were determined to find the truth about this lost world. They knew that if they could find the right rocks, they could prove Zealandia was real. So here is the deal. They spent years on research ships fighting waves and weather to reach the most remote parts of the Pacific. The mystery of why this one piece sank while the others stayed afloat is still being debated today. Proof: hiding under the mud. Mapping an underwater continent requires more than just looking at it through the water. You need physical evidence like actual rock samples that can be analyzed and dated. That is where the expedition to North Zealandia came in. The research team focused on Fairway Ridge in the Coral Sea, which was the final unmapped section of the continent. They used dredging equipment to scrape the seafloor and scoop up rocks from depths where sunlight never penetrates. The pressure down there would crush a human instantly. What came up in those dredges was remarkable. They found pebbly sandstone containing fragments of other rocks worn smooth by ancient rivers. They found fine, grained sandstone that formed in calm water environments, and mudstone that settled in quiet ocean basins. They even found limestone made from the shells of long-dead sea creatures. Each rock type represented a different environment and a different chapter in Zealandia's geological history. The researchers analyzed the chemical composition of these samples to identify minerals that revealed how the rocks formed. Dating the rocks required very advanced laboratory techniques. Some samples contained radioactive isotopes that decay at known rates, which provided a geological clock to pinpoint their age. Other rocks were dated by comparing their magnetic signatures to known patterns in Earth's magnetic field. The sandstone from the late Cretaceous period was roughly 95 million years old. Back then, dinosaurs still roamed the Earth, and Zealandia was just starting to separate from its neighbors. The granite and volcanic pebbles dated back to the early Cretaceous, which is up to 130 million years ago. This was evidence of ancient mountain building events and volcanic activity that happened before the continent split away. The basalt was much younger and only about 40 million years old. By that time, Zealandia had already sunk beneath the waves. These volcanic rocks formed on the seafloor itself long after the continent was submerged. By combining rock dating with magnetic data and seismic imaging, the research team mapped the major geological units across North Zealandia. They identified ancient fault lines, volcanic zones, and sedimentary basins. These are all the features that define the structure of a continent. With this final piece in place, they completed the mapping of the entire Zealandia continent. The researchers stated that this work completes the geological mapping of the entire Zealandia continent. Scientists finally mapped Earth's hidden eighth continent, and for the first time, they could see the whole picture. What they were looking at was stunning, but it also raised an important question. If this is truly a continent, why does it not look like the others? Everyone is obsessed with the idea of a lost city like Atlantis, but the reality of a lost continent is much more interesting. The real question is whether we should change every map in the world just for this one discovery. A world we only just mapped. The recent completion of the first comprehensive map of Zealandia, Earth's hidden eighth continent, marks a milestone in our understanding of planetary evolution. For decades, the existence of this vast landmass was more of a geological hypothesis than a proven fact. But we now have a high-resolution picture of a continent that is 94% submerged. This discovery naturally invites a fundamental question. Why does this matter? What difference does it make to map an underwater territory that most humans will never set foot upon? The answer lies in the unique way Zealandia serves as a geological time capsule, preserving records of Earth's history that have been lost or destroyed elsewhere. Zealandia preserves geological evidence that does not exist on any of the other 7 continents. Because the vast majority of its 5 million square kilometers sank beneath the ocean relatively quickly after breaking away from the supercontinent Gondwana, it avoided the relentless erosion processes that constantly reshape and erase the history of land masses on the surface. On land, the cycle of wind, rain, ice, and river flow wears away rock at a steady, aggressive pace. Mountains are ground out into valleys, and coastlines are perpetually reshaped by the elements. Over millions of years, this terrestrial shredding means the geological record becomes scrambled, buried, or entirely destroyed. In contrast, underwater erosion functions on a different scale and rhythm. While deep ocean currents can move sediment, the process is significantly gentler and more predictable than the mechanical weathering found on the surface. Beneath the waves, rock formations remain intact for much longer periods. For geologists, studying Zealandia is like finding a book with no pages torn out. By examining the layers of rock and sediment across the submerged plateau, scientists can observe the mechanics of continental breakup with a clarity that is impossible on land. The specific stretching mechanism that thinned Zealandia's crust until it eventually sank suggests that this type of continental stretching might be a far more common geological event than previously thought. It is possible that other continents separated through nearly identical processes, but the evidence of those transitions was erased by millions of years of weather and tectonic recycling. Zealandia provides a complete, frozen-in-time case study of how a continent dies and disappears. This research also provides critical insights into the relationship between the movement of continents and the rise and fall of sea levels. When Zealandia began its long descent into the Pacific, the displacement of land and the opening of new oceanic basins caused massive shifts in water distribution. As the land sank, ocean water rushed in to fill the gaps between the separating masses of Australia, Antarctica, and Zealandia. These changes did not just affect the local geography. They altered global sea levels, which in turn reshaped ocean circulation patterns. Because the ocean acts as the Earth's primary heat distribution system, these changes had a direct and lasting impact on the global climate. By tracing the exact timing and speed of Zealandia's submergence, Scientists can create more accurate models of how physical changes in the Earth's crust drive long-term climatic shifts. The implications extend into the biological world as well. Climate and geography dictate where plants and animals can survive, migrate, and thrive. As Zealandia drifted and eventually submerged, it created a series of shifting land bridges and isolated islands. Species were forced to either adapt to a shrinking environment, migrate across narrowing corridors of land, or face extinction. By mapping the history of this continent, biologists can better understand the ghost lineages of plants and animals found in New Zealand and New Caledonia. These modern ecosystems are the visible tips of a much larger, submerged evolutionary stage. Understanding the timeline of Zealandia's sinking allows us to map the connections between isolated species and better understand how the physical evolution of the planet shapes the biological diversity we see today. Despite the success of the recent mapping project, large portions of Zealandia remain a mystery. The latest maps have documented the extent of the continent and its major structural features, such as the massive ridges and basins that define its shape. But the finer details are still hidden beneath kilometers of water and sediment. Scientists expect that the next phase of research involving deep-sea drilling and the use of advanced autonomous underwater vehicles will reveal even more about the composition of the crust. Each rock sample pulled from the seabed and every magnetic reading taken from a research vessel adds another layer of detail to our understanding of how the Earth's surface reshapes itself over vast spans of time. This line of inquiry has vital practical applications that go beyond academic curiosity. Knowing how continents moved and thinned in the past helps geophysicists predict how they might move in the future. A deeper understanding of plate tectonics and crustal deformation is essential for predicting the long-term behavior of fault lines, which can improve our ability to assess the risks of earthquakes and volcanic eruptions. Zealandia is not merely a geographic trivia point. It's a natural laboratory for studying the fundamental processes that affect every person living on this planet. The mapping of Zealandia proves that even in an age of satellite surveillance and global connectivity, major features of our planet can remain hidden for centuries. It took the development of specific sonar technologies and satellite altimetry, which measures the shape of the ocean surface to infer the structures beneath, what was right in front of us. For now, the scientific community continues to process the data collected from the deep Pacific. The complete mapping provides a solid foundation for research that will likely span decades. Is Zealandia truly a continent, or just a massive piece of ocean floor that scientists are overhyping to get attention? This discovery changes everything we thought we knew about our planet's layout. What else do you think is hiding under the waves? Let us know below and make sure to like and subscribe for more mysteries.